All right, so if you watched the kind of the first video, I talked about snowballs, and so this is what this one is doing. We have a spherical snowball, it's melting, and the radius is decreasing at a constant rate. So, no matter where it's a constant rate of decreasing. And it says its diameter decreased from 24 centimeters to 16 centimeters in 30 minutes. Now, if you think about that, if we're decreasing at a constant rate, that's going to give us a rate if we go and say the latter, 16, minus the former 24 divided by the latter, the 30 minus the former at time 0. Well, the minus 16 plus, or 16 minus the 24, I should say, over the 30, that's going to give us what? Well, that's going to be a negative 8. That's going to be over 30. And we could reduce that, but we'll just leave it for that right now, and negative 8 centimeters per minute. Okay, so that's kind of our rate we need eventually. And so now it says, what is the volume of the snowball when the radius is 10 centimeters? Okay, well, we can find volume. Remember, what is the sphere of volume is going to be equal to 4/3 pi r cubed. And so that's going to be our formula we're going to use. And now how quickly is the volume of the snowball changing when its radius is 10 centimeters? So that's when we have to do some derivatives and come into all that. And so what we need to do now is go through our steps. So let's do step 1. We have our dependent and our independent. All right. Well, independent is going to be time, and that's going to be in minutes. And our dependent, well, we're going to have a volume, and that's going to be in centimeters cubed. And we're going to also have a radius, and that's going to be in centimeters. Okay, so that's because we know kind of with the volume of a sphere, we have to have that radius, and then that's going to be the volume. And so with step 2, then, what we can do is we can write everything into an equation. So that's volume equals 4/3 pi r cubed. All right. Now, what do we do? Well, now we can do part A because we have our equation. Part A says, okay, well, now we need V of 10. Well, that's 4/3 pi times 10 to the third. And so if we plug that into our calculator, if I do that real quick, 4 divided by 3 times pi times 10 to the third. And that gives us 4188.790205. So let's write that as just 4188.790 maybe. And that's going to be centimeters cubed. So that is what we need for part A. Now part B, we have to take the derivative of this. So step 3 is going to be the derivative. So we're going to take d dt of v equals d dt of the 4/3 pi r cubed. Well, that gives us dv dt equals, now the derivative of this with respect to r, well, that's going to bring down to 3, and then that'll give us 4/3 pi times 3r squared, and then we'll have dr dt. Now that 3 and that 3 cancel. We have 4 pi r squared. So dv dt equals 4 pi r squared dr dt. Now, do we know anything? Well, yeah, we know r is 10. So we got that. We know dr dt. Well, we figured that out at the very beginning because we knew we was going to have to figure that out eventually. And so step 4, we know r is equal to 10. We know dr dt is equal to negative 8 over 30. And so this is centimeters per minute. Plugging that all in, we're going to get dv dt equals 4 pi times 10 squared times negative 8 over 30. And again, I'm just going to put it as it is without reducing anything. And so when I do that, I have 4 times my pi times 10 squared times negative 8 divided by 30. And I get a negative 335.1032. So we'll just call it 103. And that's going to be the change in volume with respect to time. So that's going to be centimeters cubed per, and it's in minutes. So centimeters cubed per minute. So that is going to be the change in volume at that radius of 10 centimeters. So that's what we got there. And again, all we had to do was take the derivative with respect to r on the right and with respect to v on the left, and then plug in everything we knew, and we got our change in volume. Okay, so that was a pretty easy one. All right, so let's do another one.